Hello, my name is Jacob Thompson, and today we're going to be discussing hypothesis testing and visualizing those tests. The agenda for this talk, we're going to be going over what a null and alternate hypothesis is. We're going to look at some visualizations, specifically testing for a mean, comparing two groups, efficiency comparison, and correlation tests. We'll go through some important takeaways and then answer any questions. So let's talk about hypotheses. When we talk about a hypothesis, we're talking about what it is we'd like to study. For instance, does A have an effect on B? And this hypothesis has to be testable. We have to have a way to either prove or disprove this hypothesis. So these hypotheses are written in two ways. One way to write that is what we call a null hypothesis. And the null hypothesis expresses no relationship between variables. So this is set up to provide credibility to the study. So in essence, what we're saying is with the null hypothesis, A does not have an effect on B. And we would try to prove that. The alternate hypothesis is written to where it does express a relationship, where A does have an effect on B, and that's what we're trying to prove with the study. And written these two ways provides us a way to test this hypothesis for credibility. So let's take a look at our first visualization. We'll be testing for a mean. Our research question here is, on average, are the widgets from Acme Widget Company defect-free? So in this case, would write our null hypothesis as the probability of defects is 0 per 100 widgets produced, or the probability of defects be equal to 0. And our alternative hypothesis could be written as there is a probability of defects per 100 widgets produced, or that probability is greater than 0. So when we look at our visualization for the test here, it looks like the probability of 0 defects is 40%. So 40% of the time that we're producing these 100 widgets, we're going to have 0 defects. And that starts to drop off, that probability starts to drop off when we look at the number of defects. So for one defect per 100, we're looking at about 25% probability, down to 0 for 4 defects. I think in this case, we'd need more information on what does defect-free mean in order to accept or reject the null hypothesis. At face value, it looks at, because there is a probability that we do have defects per 100 widgets, I think we, without more information, would have to reject the null hypothesis in this case. Now let's look at visualization number 2, comparing two groups. Our research question here is, does the average major league team have more home run hitters than its corresponding minor league team? So here our null hypothesis could be written as, there is no difference in the number of home runs for major league teams and their minor league counterpart, or the sum of home run hitters for major league teams equals the sum of home run hitters for minor league teams. Our alternative hypothesis could be written as, major league teams will have more home runs than their minor league counterpart, or the sum of home run hitters for major league teams will be greater than the sum for minor league teams. If you look at the visualization, we do see that there is slightly more total home run hitters for major league teams than minor league teams, but if we look at the fraction of the team that are home run hitters, it looks like somewhere between 35 and 40% of major league teams have 16 home run hitters, whereas only between 25 and 30% of minor league teams have those hitters. And those look like they're about equal between 30 and 35% of the time, where we have each team has about 7 home run hitters. So in this case, I would say we would reject the null hypothesis because there is a difference in home run hitters on average between the two teams. Okay, let's look at visualization number 3. This is a comparison of efficiency amongst, looks like servers. Our research question here is the efficiency curves of the red and blue teams were recorded. Do the teams have equal mean efficiencies? So in this case, we would write our null hypothesis as there is no difference in efficiencies between the red and blue teams. And our alternative hypothesis could be written as there is a difference in efficiency between the red and blue teams, whether that's positive or negative. So when we look at the visualization here, they were not observed for the same amount of time, but if you look at the red team, it looks like they were observed for 10 hours, and they served roughly 30 customers per hour. For that would be a total of 300, so 300 people served total. Whereas the blue team were observed for 4 hours, and it looks like they served roughly 50 people per hour, so that would be a total of 200 people over that 4-hour period. If you average that over 10 hours, I would say the blue team is more efficient than the red team. So in this case, we could reject our null hypothesis that there is no difference, because there is obviously a difference in efficiency here. Okay, let's look at our final visualization. This is a correlational test. Here, a German study tested how larger industrial use vans utilized gasoline. So they were trying to correlate miles per gallon versus the weight of the vans in the study. However, they forgot to state their hypothesis test after they found a significant correlation. So in this case, our null hypothesis could be written as there is no correlation between miles per gallon and van weight, or correlation is equal to 0. And the alternative hypothesis could be written as there is a correlation between miles per gallon and van weight, or that correlation is not equal to 0. And in this case, it is clear to see as the weight of the van increases, miles per gallon does decrease. So there is a correlation there, negative correlation. As one increases, the other decreases. Okay, so let's discuss some important takeaways from this presentation. Talk about creating hypothesis tests. Like we said, hypotheses must be testable in order for them to be credible. If you can't test your hypothesis, then there's really no way to say definitively that we accept that test, or our test has any valuable or our hypothesis has any valuable information. Hypothesis must be testable in order for us to say yes or no, I did have findings here. And our null and alternative hypotheses provide that means for testing. We can either accept or reject that null hypothesis, and then revise our hypothesis, and then move on from that. Using visualizations is important. When we talk about using visualizations, such as charts and diagrams, these reinforce the instruction. These reinforce what we're trying to convey. A chart gives better information, a better visualization of what information you have written down. And then when you narrate, you're able to provide more meat on the bones and give some detailed information on the bulleted topic items that are there. Very important thing, using visualizations. And that's all we have. Thank you for watching, and please post any questions you might have. Thank you.